Get going. Okay. Good morning and welcome to TRC Tech Talk. A few bookkeeping things. This is being recorded. If you have any questions, feel free to put those into the Q&A or into the chat. We'll try to answer those either live or respond in those formats. And we will begin. So today we are going to be talking about some really serious HMI stuff, and hope you got your waders on because it's going to get a little bit deep. Basically, we're going to be talking about global objects and faceplates. So a lot of FactoryTalk View fun things. So today presenting myself, Joe Belaski, one of the automation and network specialists out of Houston. We do have a few other people on the line on the panelist side. Brian McKeska, Mark McGinnis, Mike Masterson, Wayne Welk. They'll be helping me in chat and in the Q&A, or possibly just heckling, which I'm always open for. We have a couple of upcoming events. We have a users group coming up on the 17th about scalable OEE, and we have a couple of tech talks coming up as well. So we've got HART, highly integrated HART on March 24th, and then a Win 911, so alarm notifications for industry and IoT, and some machine learning and AI industrial applications. So make sure that you sign up for those. And with that, I think we're going to get into it. So we're going to be talking a lot about faceplates and global objects. And the easiest place to start with all of these is actually Rockwell's PlantPAx library. Now I'm going to be using Rockwell's PlantPAx library as a reference, and I'm going to be talking a little bit about how it's done in there and how you can get access to it and all of the other fun pieces with that. Using this as a platform to jump off of to create anything that you want to create on your own. You can use these as starting points. They're completely open source. You can modify them, play with them however you want. And so we're going to get into a little bit deeper dive on how to use those. But I figured I'd start with what are the objects. So Rockwell has this library of PlantPAx process objects that are free, a free download, and they include both pieces, and actually multiple pieces. They include typically an add-on instruction, which goes inside the controller, which from a faceplate perspective, we're looking at that purely to create user-defined data types and data sets and stuff for the faceplates to reference. It also includes a drop-in global object for your screens, and then the pop-up faceplates for when you click on that object and to get a deeper dive into the information. And so going forward, we have a few new process controllers that actually just came out. So anybody that's familiar with our process objects knows about the add-on instructions and some of the memory and other pieces that go on, utilization stuff that goes along with those. And we've come out with new process controllers that have these built in and also have the guardrails built in around being used in process applications. So just wanted to let you know that these are available now and can simplify the deployment on the controller side. As far as the controller side goes, I probably have 2 or 3 more slides about that mixed in among the rest of this. We're not going to spend much time about it. And let me know if I'm talking too quickly, because I'm going to try to get through a lot of material fairly quickly. So the benefit of the library is that you can reuse code. So that's really the main thing, is you're trying to cut down on time of engineering. You're trying to simplify maintenance. You can prove the code out once, know that it's usable and right, and prove out the HMI components once, know that they're going to work, and you don't have to go back and make changes to them. Or if you want to make a change, you make a change one place, and it filters down to all of the uses. The library is pretty substantial and has a bunch of additional pieces to it. A couple of the main things about the Rockwell library is it also includes user roles and a couple of other things in there for being able to give permissions on who can see what. and we'll get into a little bit about how that's done behind the scenes. But that's one of the key things is it's not just the generic faceplates, it's faceplates that allow you to see different pieces and control who can access what. They also give you additional configuration and other capabilities as well as far as how the code is executed and what's going on. So looking at what objects are available, what's typically included in this library, you've got the logics objects, you have FactoryTalk View SE and ME objects. So I'm going to specifically, my screenshots that I took are from an SE environment, but really the functionality is effectively the same on the ME environment. And I'll give comments about some of the subtle differences there. It also includes reference manuals, add-on instructions, additional stuff, and a couple of additional things that we can look at. Some of the key additional things are motors. We can do single speed, variable speed drives. We can look at power equipment, valves. We can interrogate controller status. There's a lot of additional pieces inside of this library, especially in this new version 5 of the library. And so going forward, where can I get the library? So can I have it already? There's a link here. We will be sharing these screens, but basically if you just go to ab.com and look for the Find Downloads button, it'll take you to the compatibility and downloads page where you can select Find Downloads, type in PAX, and look for the process library, and you can see we're at revision 5.0001. I took these screenshots last night, so they should be very current. So that this is one of the main places you can go to get these, and there's additional pieces in there for PlantPAX, but the library is one of the main things. When you open that up and go to do the downloads, it will ask you which different variants are available, which ones you want to use, and so there's a bunch of different pieces inside this PX library where I was talking about some of the power equipment and stuff like that. So you can select the pieces that you need when you go to download. So to use the library, step one, unpack it. And then once you unpack it, you can go use it in the controller. And so basically the deployment process for this is pretty much the steps that I'm giving you here. So step one is install the add-on instructions that you're going to need. Key takeaway here is if you're not using one of the process controllers, there is a large list of add-on instructions and they do take up space, especially when you go to deploy them. So you don't want to be putting every add-on instruction in there unless you need every add-on instruction. And so you import the ones that you need, typically only the ones that you need, just so you don't waste space. And it also makes it more complicated to diagnose and stuff when you have a list of AOIs and half of them are not being used. So when you import all of those, it will import the pieces that come with it. So when you do like a P motor, P_motor add-on instruction, it will bring in the P_mode and the P_alarm functions that are used within it. So it will bring in all of the appropriate data types. It'll bring in the appropriate strings. It'll bring in the appropriate other add-on instructions that are embedded inside of it. So it makes it a very clean import. Now, some of the additional pieces that come in when you look at some of these elements, especially when you look at ones for like our PowerFlex drives, which are very, very well put together. Those ones actually include additional pieces for rung and additional information that you can import, and you import at basically the rung level. And the reason you would go and do that to grab that extra bit is it actually brings in this fault code lookup table. So as part of those add-on instructions, they actually go through and say, well, what's fault? Let's see, let's find a good fault. I think 111, which is a safety fault, out of phase, basically where one of the channels is faulted and you effectively have to power cycle the drive. And it would actually tell you in that list, it would go through the list and say, oh, well, I've got a fault 111 code coming from the drive. What is that? And gives you the string information for that. And it's already built for you, so you don't have to go look it up and make it yourself. So very, very useful. To answer that question about, will this presentation focus only on the faceplates available with PlantPAX and modifying them? Basically, yes. I am going to dig into how they work at the end so that you'll be able to create your own. A lot of times it's easier to start with something that's already built. So that's the reason that I'm looking at it from this perspective, is to show you how they work behind the scenes. And so if you wanted to make your own, the steps you would use to make them are effectively there. Uh, Good question. Um, So once you've imported the rungs in the add-on instructions, you will try to install the HMI components. And so this would be consistent. And if you're making, even if you make your own library, so if you're not using the PlantPAx library, but you make your own elements, you develop your own custom pieces, you will end up effectively having that on instruction or having a piece of code that you'll drag into the controller, and you'll have a piece on the HMI that you'll need to use, which will typically include additional images for your faceplate and additional global objects, and then importing displays. And you'll want to make sure that you do those in that order because they're the way they're referenced. So you bring in the smallest pieces, the images first, and then the global objects, which reference the images, and then you'll bring in the displays that reference the global objects. So in the case of the PlantPAx ones, that's the order. This stuff already exists, but if you're making your own, that is again the order on a new project that you would want to bring these elements in. So as you build your own library of faceplates and templates and stuff like that, that's how you would transfer them project to project and bring those in. Um, and then the last step is typically going to be adding, if there's any additional requirements like tags or macros or things like that, that would be the last step that you would add in. So when it comes to displays, you want to make sure you bring in only the ones that you need. You can bring in the graphics, you can bring in the global objects, but the displays is typically the part that goes against your licensing. So when you're looking at FactoryTalk View licensing, we're typically is sold based on up to unlimited displays, but when you're looking at those display faceplates, they only take up one license or one display. If you put in 100 drives and you end up using the faceplate 100 times, it still only counts as one because it's just one element and you're calling it 100 times, but it still does take up that one display count. So if you're dealing with a lower license count, you definitely want to make sure that you compartmentalize your system and only use the ones that you're going to need. Or that if you're going to have a license, an unlimited license, I guess you can bring the entire group in. But that's something to keep in mind, even when you're building your own faceplates, is how you want to organize and structure your system so that you don't end up with an out-of-hand system that's got more displays than you have license, or bumps you into the next category just for the purpose of having those available. Um, so you bring those in, and then the next step is to create an instance in Logix, and the real reason we are creating an instance in Logix is really to create the tag and the user-defined data type that we want to reference. So that's, the next step is to be able to, within the view side, to have a tag that's available that has the appropriate data type. The one main thing here that I do want to talk about on this data type is that most of the add-on instructions that we're using, or instructions that you may end up using or creating, would give you the data type. The instruction itself gives you the data type. You can also reference your own just general UDTs. So if you wanted to make your own universal data type, user-defined data type versus a add-on instruction, you could do that as well and use those and reference those from the HMI. One of the key benefits of faceplates is the concept of parameter passing. And so that's where these structures come in very handy and are very useful. So it's important to make sure that you're using one of those data structures to simplify the parameter passing and the number of parameters that need to be passed and so on. And so once you create the add-on instruction, you connect it to the IO, configure it however you want to configure it, do all of your interconnections, your inputs, outputs, map them however you want to use them, and then move on to the FactoryTalk View side. So at this point, we've already drug in the global objects. We've already brought in the PNG images. And so you end up in a situation where you're looking at what we're seeing here, where we have the global objects, and down in the list of global objects, we have this P motor object, and there's a bunch of different faceplates there, a bunch of little global objects there. Those aren't faceplates, and those global objects contain all of the different images, and they've got a bunch of visibility and a bunch of other configurations in them that allow things to be displayed dynamically. And you just basically grab whichever one fits your orientation or whichever one you want and use it inside of your HMI and basically copy it and put it onto one of your displays. So that really is the next step. And then you right click on the one that you've deployed onto a display and say global object parameter values, and you go in here and select the tags. So the key part here is going to be this tagging piece, and this is where we're getting into the first part of the magic. So, I think 16 minutes in, making good time, got room to actually digest some of the stuff coming up, which is actually the meat and potatoes behind how all of this stuff works. So the different tags that you bring in basically are tied to data types. So you want to make sure that when you're selecting these, that you have the appropriate information, the appropriate data type selected, and we can put in different parameters and which numbers and what they mean. So basically, in the case of PlantPAx, this is the last step. You bring in a PlantPAx object, you bring in the faceplate, you tag it here, and you go home and eat popcorn, and you're basically done. And the next step after that is go do some parameterization and go worry about other parts of your code and move on. But for the case of what we're trying to do, we want to go in a little deeper and see how this stuff works. So step one is let's look at what these pieces are. So when looking at these global object parameters, we can change it and look at the definitions of them. And so in a similar case, but looking at this previous slide, where we would right click and see those global parameter values, if you actually look at that element down in the global objects section, you'll see that right below that is a global object parameter definitions, which is grayed out because this screenshot was done from a display screen. This will open up this global object parameter definitions where you can actually go in and say, what name do I want to use, typically starting at 100 and work your way down. And then what definitions do you want to associate with them? And so at this point, we're basically using this pound or hashtag 102 as a placeholder for a tag name. And so what we'll see in the next slides is how these are kind of displayed out and how they're used. In this case, looking forward, there's a couple of additional pieces of information that are included in this list specifically to the Rockwell PlantPAx ones, where we have an X location and a Y location where you can actually put a tag value or you can put in a constant or something in there to give additional information as to where you want this pop-up to be located, so it doesn't pop up over top of something else or comes in, so you can have multiple pop-ups and they sit on top of the thing they're supposed to be. There's different ways you can make these work, and that's really the XY location there, and that's part of a parameter passing. The last element here is parameter 1202 or 122, my bad, which is really just kind of a 0 or 1, and it basically shows which type of faceplate you want to pop up. And this is in the PlantPAx world. We've got a couple different. We have a small quick display faceplate, and then we have the full one. But this is a way of kind of going in and saying, well, which display do I want to actually open? So if you're trying to make multiple faceplates or give different permissions and give different people different options on what they're going to see, this is one way to do that, where you can put in a value in there and say, who's going to see what, or what do we want this to open up as? And keeping in mind that each of these is a placeholder for a tag. So we can either make those tags be like a logical string, just a constant, or we can actually put in a variable there, and that variable can be basically a tag and let us say, okay, well, what do we want this to be tied to? So moving forward, we have this hashtag 102, and is a tag, and what we're using this for, and if you look off to the right, I have this go PM motor underscore pump R, and below that are all the elements inside of it. So if you look, there's the pumps, and kind of highlighted in the middle is one of those pump elements, global objects. And these are all of the elements inside of it. So this is inside of the Object Explorer. And within those, you can go in and right click and look at connections and look at properties and look at all of the additional pieces where you configure the elements inside of these little global objects. And within here, we use this tag, and we're basically referencing hashtag 102 dot status underscore estats. And so that is now an element inside of that UDT. So if we were to go back into logics and look at the user defined data type or the add-on instruction, there would be an element dot sts underscore ests. And that is what we're referencing with this faceplate. So even though we don't know the specific tag that we're going to be looking at, we know how it's structured and we can define based off that structure. This is where the UDTs are very, very important and make life very easy. Another instance of this is looking at a different element. So we have this not ready indication, which is basically a little stop sign, and there's a visibility element on it. So if you right click on it and looked at it there, and it would give you the options of, connect parameters and so on. In this case, visibility was set where if this status not ready is true, it will show up visible as a red stop sign saying, hey, the pump isn't ready for whatever reason. And that's tied to this, status underscore not ready tag being used inside the code. And so this is how you set this up. So every time you want to add an element here, you just go create your display object, you put it in here and embed it inside of this group. And then you just go in and set all of your tags that you want to use. But instead of using the first part of the tag where you're actually looking at a direct PLC or controller reference tag, you take the front part of that off and replace it with this pound 102 or pound 105 or whichever one you make. So this is a very important piece of how we can compartmentalize and do a lot of parameter passing inside of the HMI. This is how you simplify, so you only have to design it once. It takes a little bit longer because you're doing it this way, but if you're going to deploy it more than 3 times, you're definitely time ahead. So looking at another element of this, so navigation to the faceplate. So again, looking at the exact same pump setup, I selected a different element now. So I'm down toward the bottom of the list of the elements, looking at just got a question. Please talk a little bit more about where we can use of library 4.1 and 5.0. I'll get into that in a second. So we have a couple different things here, but basically on the navigation side, there was effectively 2 different nav buttons. There's this quick and faceplate. So if you look all the way to the right, I have kind of highlighted this a little hard to see. We have this nav button to underscore faceplate. And so you've got this navigation button, and what it does is it's got this little string inside of it. And so this text there basically says nav to display in a couple of different elements inside of it. Looking to the left and down at the bottom, we actually have visibility things, and this is setting a different button, giving animation to the quick button on top, which is overlaid on top of the other one, basically saying which one of these buttons do I want to use. So the first one actually has this visibility on it, and so we're referencing again this pound 122, depending on what the value is. So if it's a 2 or a 1, and not user code, user has code, security, show faceplate. And so there's additional stuff in there about security and who can see what. And that dictates when you click on that element, that pump, where you're going to go. So creating this on your own, you would basically create this button and say, okay, when I hit this button, I want to go to a display. Or if I want to be variable, I can now start stacking display buttons and using visibility functions. And we can use expressions in there. So it's not just a tag. We can use expressions to say which one of these displays do we want to go to, and using these pound tags as indirect references so that we can dynamically change things. So this is one of the ways that we have it set up for us to be able to do that. And this is something that you could very easily mimic in order to manage getting to the faceplates and making sure that you're opening the correct one. Now in version 5.0, we changed the way that we're doing some of the launching of these faceplates, and that's part of this release action. This nav2 display is actually a macro that we're calling. And in version 4.1, we were doing it a little more direct than with the macro. Either way, there really isn't much of a difference there. And so I'm going to get into the macro on this next slide. And so basically what this macro is doing that we're calling is selecting which parameters to pass to the display. And so really what this is doing is it's going to open up the display, and it fairly well documented for a very short script. And basically all it is doing is giving you additional information and taking the parameters that are available and pushing them into the new faceplate that you're popping up. So object number one is nav2 display. So that's calling this script. And then we're object tag name is coming from this first element. So, and then we've got pass-through information, and then we've got display type, and then we've got then display parameters, so parameter one and parameter two. And so we're using those in here in each one of these sets of quotes. So, the different parameters that we're trying to pass to it are coming from this release action. And so it'd be very easy. And this is one of the pieces where I like starting with stuff other people have already done. And this is, again, open source. So feel free to play with it and do it, make it however you want to. But you can also start with something very similar from the Rockwell perspective that we already have built for you. And using a macro like this or something so you can populate and quickly populate stuff to the displays. Now there's nothing to stop us from adding in a %6 or something like that and adding additional display parameter files that we want to pass or additional pieces that we want to push to the to that display. But this is where they're coming from. I wanted to make sure you could see on here that this what %1, %2, %3, where all these are coming from. And they're basically coming from these pound 102, pound 120, and pound 121. And so that's basically what we're looking at here. So I know this is a little bit to digest, especially if you're not into macro programming and stuff like that. But this is how the data flows. So initially we did the parameter configuration, set up the parameters. We now call the parameters, pass them into a nav2 display script, which is going to pop up the appropriate display and pass those parameters to it. And so when the display pops up, we are still looking at the appropriate motor information. So getting into the faceplates and looking at those specifically, we have a little bit of information on how these things are set up. When you open up one of these faceplates and you look at the Object Explorer, it's a lot of information and stuff stacked on top of itself. There is, in the case of the Rockwell faceplates, there's a macro to change between the different functions to bounce back and forth between maintenance and other modes. Now, if you're building your own faceplate, you may not include those pieces and you may not need that macro. Typically, most people, when they're building their own, don't get to that level where you just pop up a more of a standard, pretty set faceplate where you're more playing with visibility of individual elements and what's going to be there. What's going to be displayed, what's going to be interactive, and what isn't. One of the key things to look at when you're building one of these faceplates, though, is typically we're still using our global objects. So the piece here to look at is down in the bottom middle is this faceplate template, and within there, under one of the modes, diagnostics mode, is this element that I have device out of service is highlighted, and so you go in there and you try to figure out, okay, well, how do I tag this? How do I make this work? How would I make this happen? How do I get information to it? And you kind of pound your head against the wall for a little bit going, I don't understand how this works. The easiest way to understand this is that is not created there. That is actually a reference to a global object. So if you go down and look at the global object diagnostics, so you up at the top right, we have this device out of service, and you notice it has a pound 2. So it's looking at the second, at a parameter file basically that's being passed to this faceplate. And then it's looking at the status underscore not ready OSO. So, or OOS. So it's got this piece tied to it. So we're using a different, notice that we've got a pound to or hashtag, whichever you prefer. I'm a little old, so I use a pound, pound 2. And you look at that and that's like, well, that doesn't tie to pound 102 that we were referencing elsewhere. but that's what that macro does, is passes that pound 102 into the faceplate, into the appropriate one. And so the number may actually change as you're going through. And so it's something to keep in mind and important when you're designing these. So when you're playing with your faceplates and you're starting to build a faceplate, you're typically going to be dragging in a bunch of global objects. So you're going to spend 90% of your time playing in the global objects and maybe 10% of your time actually organizing the faceplate. The rest of the time you're going to be playing down into global objects, creating the elements that you want to display on the faceplate and parameterizing them as global objects so that when you put them on the faceplate, they're referencing the appropriate parameter, they're referencing the piece that you want. And then when you go to deploy them, you're using a separate global object or some other button to call this faceplate to pop up. And you're going to be passing the parameters to those specific elements. And in general, that's the meat and potatoes of how these things work behind the scenes. And if you were to design your own, you would typically start dealing with specifically global objects and work your way up from there, keeping in mind that you would be also with one foot inside of Studio 5000 or managing your user-defined data type and making sure the data that you want is available. And when you're designing these things from the ground up, you're typically doing both. And the way I look at it, some ways when I'm designing these pieces is, well, step one, you can do it from the engineering perspective. I'm going to sit down and try to figure out what all the stuff I need, build my user-defined data type, build my data structure, and then go build my HMI. There's the other method, which is just let's go for it. And if you're doing the let's go for it method, you typically start in the HMI, figure out what you need, and continuously add things to your user-defined data type or your add-on instruction, and then make sure you go back in and add the code to support those while you're doing that, or make sure that you make notes to go do that after the fact. So yeah, you've got a tag showing status, but we never built the code to actually run it. But when you're building these, that's basically what you're going to be doing is global objects 90% of the time, and then dragging those and implementing them on your faceplates, and then tying in different pieces on those. So the standard pieces we already use, going to be security, visibility, tying in security within the visibility, and then pulling in additional parameters from the controller, and you can manage different things in different places. So on the SE side, we typically do a lot more with the security and stuff is coming from the HMI. On the ME side, sometimes you'll see it both in the controller or in the HMI, because you can typically only have one display running off of a controller. Where on the SE side, we're typically running multiple displays running off of one controller. So the controller can't really manage who's seeing what, because you could have multiple people with different credentials logged in at the same time. So we typically look at, security is more of an HMI function than in a controller function. But there's also additional pieces you can do within these displays and stuff where you can map pieces in from the controller to basically gray out buttons that aren't going to be there. So you can basically put an image of a button on underneath the actual button and make the button disappear if you're not supposed to hit it. If you're not supposed to be able to hit it, if you're in the wrong mode or something like that. So you can see that it's grayed out and it looks like it should be there, but it isn't working. Something very similar to the way that we typically would expect from any of our other software that you would use. You have the drop downs at the top, and you do a drop down to go edit, and the one piece you want to do, like a find replace or something like that, is grayed out. You're like, well, I must be in the wrong mode, or I must be missing something because it's grayed out. Why won't it let me do it? And so similar stuff we can do on the faceplates, where you can gray out buttons so that people know that they're there, but they don't work. So at this point, I think I covered a majority of this. The key thing here is that the Rockwell does have a lot of documentation on the ones that we've built. There's constantly more documentation coming out about how to use them and how to implement them. The main thing is they're all built basically on the same format. From an ME perspective, there's a few subtle differences when you're getting into these, and it's got more to do with functions of buttons and things like that. ME is a little bit more predefined than SE is, and we typically use the macros a little bit less in the ME side, but they're effectively very similar. And that's really kind of the main difference between you deploying these in an ME instance versus an SE instance. Um, Alarming and stuff like that is obviously different, but that's not typically something on the faceplate. On the faceplate, we're typically doing more of a Boolean alarming, uh, tag based alarming from the controller, where we're passing using tag values to illuminate that there is something wrong, and then in parallel the alarm and events or the alarm function is grabbing that same value and looking at it. And then going from PlantPAx 4.1 to 5.0, there's been some subtle changes to the library. There's tools to help migrate from one to the other. One of the key things going from 4.1 to 5.0 is we've added a few more macros into the system. We also did a little bit more consolidation between bringing in gems and a couple of other different Rockwell faceplates and bringing those in and having some cross-reference between those. And then the addition of the process controllers, which really simplifies the control side, because at that point we're no longer looking at AOIs, they're now embedded in instructions very similar to like a PIDE. They're just embedded in the controller and you use them, drag them in and use them. And now they're firmware managed. So if you were, a year from now, we come out with version 6 or 5.1 or something different, it would just be a firmware update on the controller to migrate those forward. Where, currently with all the add-on instructions, we typically use tools and things like that to migrate the code forward. And the key thing here is when you're doing these, you want to make sure that especially if you're building your own, that you log your data structure, how it's being used, how you've referenced it, because when you go to make a change, you're affecting multiple platforms. So you go add a tag to the controller, no big deal. The HMI isn't looking for it. You add it to the HMI before you add it to the controller, that becomes a problem, because now the HMI is going to fault because it's trying to find this tag that doesn't exist. That's really one of the key things. So when we're doing these migrations, you kind of migrate things together, and also doing some revision control on your data types and on your faceplates and those structures to make sure that you understand, like, this is version 3, version 4, version 5, version 6, so that these were the changes from version 3 to 4, or there wasn't a change, like these elements, even though we've moved our library up, these pieces didn't change. We did not modify these. We didn't make a change. I think one of the last things is pretty much all of the Rockwell faceplates have that ISA standard. I think it's 101, which covers basically everything's in shades of gray, so that when things are a nice pretty blue or red or green or something like that, they're of high importance. So it's, you're not seeing a bunch of pretty colors, so the alarm, which is flashing red, is kind of drowned out by all the other pretty colors. Everything's in shades of gray typically, and then you can go in and see exactly, like, well, this is red, that must mean it's important, I'm going to go look at it. So it's easier to find those little things to follow. I know I covered a lot. I went a couple minutes over. I am constantly looking to see if there's any questions. Feel free to type in any additional questions. Reference manuals that are available currently to be able to go look at all of the Rockwell content. Again, it's a free download. You can access it today if you don't already have it. Concepts that we talked about today are the same going backwards. For the most part, there are some subtle differences version 4.1 to 5 as far as like macros and screen displays. Other than that, basically the concepts are the same. It's global objects and then build your display from those global objects, and parameter passing is really the key thing there, and being able to map the parameter passing. That building that map is probably the hardest part out of all of this. But once you get it built and figure it out, it's the part that makes this the easiest to deploy going in the future on future applications and future systems. And with that, I think I'm done. Any questions?